Okay, so we need to know how to count. And I realize that sounds really funny because you've been counting probably since you were like 2. Right now, Ginny can count, except for she doesn't seem to understand the number 5, so she says 1, 2, 3, 4, 6, which is fine. She pretends, everyone laughs, smiles, it's awesome. So, but counting by itself is pretty basic. We are going to count possibilities. In other words, how many ways are there to hand out gold, silver, and bronze to 13 gymnasts? How many handshakes happen in a room of 117 people? How many blah, 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 blah. If you go to Froyo, or we'll say Chipotle, I have 2 choices for rice, 2 choices for beans, 4 choices for blah, 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 blah. How many types of burritos can I get? That's the counting I'm talking about here. And I'm going to take you through 3, hopefully fairly quick examples on some different things that we might want to count. So the first method, so to speak, is called the fundamental counting principle. And honestly, this is probably the last time you're going to hear me say it all spelled out like that. I love to abbreviate it as FCP. And the fundamental counting principle is used when we want to count various groups. Okay? In other words, this is our Chipotle example. This is when you go to Chipotle and you count, okay, I'm going to count for the fact that I have 2 kinds of rice, and so on and so on and so on. And in doing so, you're going to end up with a lot of math. And you can make a giant list, but really the fast way to do it is to multiply all the possibilities. How many choices for rice? How many choices for beans? Okay? If we're keeping track, this is our Chipotle example. But really, we could take it anywhere. We could take it to Froyo or Cold Stone. I went there the other day. And like, okay, you could mix in brownies. You could, how many choices do you have for mixing stuff in? Blah, blah, blah. The other one is license plates, right? How many different license plates can you have in Minnesota? If we go 3 letters followed by 3 numbers, and we say it can't repeat. So I'm going to say I'm going to have 26 choices for the first letter, but then since I'm saying it doesn't repeat, it drops to 25, then 24, and so on. And then we could do the same thing with numbers. We could go 10, 9, 8. And the reason it goes 10 is because I have 0 through 9, and so on. And so you could add extra rules. You could be like, well, you can't use the letter O because it's too much like a 0, blah, blah, blah. Or you can't use a 0 because it's too much like an O. But my first car had a license plate with 011 in it. So we're kind of fudging it a little bit. But for sure I said here, no repeats. And if I want to know how many license plates I can get by following that rule, I go to my calculator. 26 times 25 times 24 times 10 times 9 times, oops. And that result tells me exactly how many license plates I can have. So we're using this for various groups, right? We have at Chipotle, we have our rice, we have our salsas, we have our other toppings and so on. There's different choices in each group. So that's when we're going to use FCP, and that's when we're going to multiply all our possibilities. The next chunk are our permutations. And permutations are arrangements when the order matters. This can look a couple different ways. This could be like a locker combination. Locker combination is probably not a good example. How about a phone number? So in a phone number, if I want to call East High School and you want to call my classroom, the extension is 3714 in that order. If you call 3741, you'll get a different someone else's classroom. And so that's a permutation because the order is specific. And since the order is specific, we count it differently than when the order doesn't matter, which is going to come up in a little bit here. But for a permutation where the order matters, a lot of times you're going to see like a title maybe. Like who can you give the gold, the silver, and the bronze medal to? Because if Miss Visto wins the gold and Mr. Davis wins the silver and Mr. Fuller wins the bronze, that's different than Fuller winning the gold, Davis winning silver, and me winning the bronze, right? The order of the outcome matters. We can have different outcomes if we change the order around. On your calculator, and if you're not sure where these are, make sure you watch the calculator video. On your calculator, we're going to use NPR. N is the total, P stands for permutation, and R stands for how many. How many things are we picking? So here's an example. 40 people are running the marathon. How many ways can we give out the gold medal, silver, and bronze? This is a permutation because the outcome has specific parts. The gold medal is different from the silver medal, is different from the bronze medal. And in this example, N would be 40 and R would be 3. If you want to see another example, 25 applicants, and we are hiring for a programmer and a manager. So and some of you are like, wait a minute. Well, no, because there's specific titles, right? President and vice president would be another case of this. If Miss Hilger is hired for the programmer and Miss Dauk is hired for the manager, that's different if we switch who's doing which job. So that's another case why this is a permutation, because the order matters, especially because there's specific titles of whose job is what. And that's kind of a key piece, is talk yourself through it a little bit. Talk yourself through, okay, my 25 applicants, if I look around the room, if I look around the school, if I give Mr. Ullman this job and Miss Weibel this job, and then all of a sudden I switch jobs, is it the same or is it all of a sudden different, right? And if it's all of a sudden different, we're doing permutations. If it's the same, then we're dealing with combinations. And combinations, I like to think of collections. Where order does not. If Mr. Darlene needs people to form a committee to talk through graduation, let's say, a committee, the order doesn't matter. If he picks Miss Evans, Mr. Brown, and Miss Hames, it doesn't matter if he says, okay, the committee's going to be Mr. Brown, Miss Hames, Miss Evans, or Miss Hames, Miss Evans, Mr. Brown. It's all one committee. It's a collection of people or a group. And on our calculator, this comes from NCR. So that's kind of the difference between the two, is the C stands for combination. Okay, so now let's take our two examples from before and say, hey, I've got 40 people running, but now I'm gonna say that the top 3 go to finals. And if you're not super familiar with like running stuff, that's fine. But basically what we're saying here is the first 3 people to cross the finish line, no matter the order, no matter if you're first or you're third, you get to move on to finals. There's no specific order tied to it, just is what it is. So that's what changes it to a combination, is now it's like a group of people moving on to finals as opposed to getting a specific order. So the numbers are the same, but the outcome's different because now it's a combination. And our calculator can tell us the difference in the outcomes. We maybe have 25 applicants, but instead of looking for a specific person to be the programmer and a specific person to be the manager, now we have 2 openings. Maybe they're both programmers. It doesn't matter if you say, if it doesn't matter the title, you just say, hey, I'm going to take 2 people. So same value for N, same value for R as the one we did before, but just a little bit different in the sense of, hey, these 2 people are fulfilling the same job, there's no difference in the job, it is what it is, and so on. So that's kind of the difference between permutation and combination. We're going to use both throughout, and you'll get some good practice, and I promise I will show you how to use your calculator, so you will do great.